Hello! Right, in this project I'm going to install two of these solar hot water panels, but instead of fitting them on the roof and using an electric pump to circulate the hot water, I'm going to mount them on the front wall of the barn and rely on gravity to thermosiphon the water up into the hot water tank. Will it work? Well, let's find out. So I've described before, I've got two different types of solar hot water systems, neither of which are actually installed at the moment. The posh sort that I have is the evacuated tube setup. This is the other sort. This is basically a radiator in a glass box. The evacuated tubes have to be pumped, so they would go on the roof and they would have to have a pump circuit to make them work. For now I quite like the idea of using these ones, and like I say, try and make a thermosiphon system. These things then are very unfashionable now, and they can be had for next to nothing second hand. I've seen them go on eBay for like a whole set for £5. I've got 4 of these, and I did one better than even that. These 4 came from a skip, so they didn't cost anything at all. I have pressure tested them, so I know they haven't popped internally, so they should be usable. The plan then is to mount those two under the windows there, then have the hot pipe coming, join them together and have the hot pipe coming from the middle up that way through the eaves, and then along there and up to the hot tank. The return line will come from the manifold that feeds the underfloor heating. It's on the other side of that door. Pop out that wall, come along there and up into those. Here we have the existing setup then. This is the manifold for the underfloor heating, and this is obviously the wood burning range. So currently, and I'll draw a diagram to show you the current setup and the proposed setup, but currently the underfloor heating pump here draws from the top of this boiler at the back here, and then it goes through the floor and returns to the bottom of the boiler. So the first part of what I want to do is to take that feed from the boiler to there and change it so that the feed comes from the heat exchanger upstairs in the hot water tank. So what that means is I'm going to have to drain down all the water that's in the heating circuit. Cool, that's fully open. Right, let's give that a few hours. Whilst that's draining then, I'll try and do a picture and give you some idea of what I've actually got in mind here. We have that as the wood burning range, and it's got a boiler in the back. Next to that we've got the underfloor heating control setup, and that goes down. This is the underfloor loop. The double doors going out onto the decking. So just above the wood burning range is where the hot water tank lives, and inside the hot water tank is the heat exchanger, which is basically a little tank inside the big tank, which means that the water that's in this loop coming out of there and into there and coming out there and into there, so the water in that loop and in the radiators never comes in contact with the actual hot water that goes out to the shower and bath and sink. At the moment then, this connects to that. So this is the feed. The hot coming out of this boiler can be drawn in by this pump and sent round the floor, and then the floor sends it back in that return. So yeah, that's more or less the current setup. I want to put the two panels here on the south facing wall, fairly low down. Hot going up, it'll go along here, and then it needs to join in to there. The return to these panels I'm going to connect to here, and that will go outside and return like that. Here I'm going to put a junction, and what I'm going to do is instead of this, I'm going to get rid of this one here and send it to there. If the sun's shining, there'll be plenty of power to power that pump at its highest, which will be extracting heat from these panels and putting it into this floor, so that in the evening it can come back out again and warm up the kitchen. With the pump off, those panels should go in there and heat up that, and I'll have a tank of hot water. The other thing I'm trying to do with this new idea is to potentially, if there's hot water in the morning, if this tank is absolutely scorchy hot, I could turn on the underfloor heating and put that heat that's in that tank into the floor, because the underfloor heating will now be pulling from there, so it will be pulling heat out of that heat exchanger, and that heat exchanger will be warmed up by heat here, I think. And that's kind of how a thermal store works. The trouble is here is I'm trying to do this with a conventional central heating tank, because I can't afford a thermal store. This tank only cost me 15 quid, and yeah, it'll have to do. We'll see. It's fun to play with anyway. Okay, what looks like a massive mess here is actually the hot water tank. There it is. This is a load of extra insulation that's normally stuffed in here, and when I finish doing these improvements I'm going to ram in even more insulation, and that's what makes the tank stay hot for so long. So that then will go there. And then the cut off piece will go back in. Right, so we've got a hole. Let's see if I can poke something in it. Might just be able to see down here, that's the feed from the boiler. That's where it goes up into here, into the mixer. So the mixer is a really important part of the underfloor heating system, because you can't put water at its hottest through concrete, it'll crack. So it has to be regulated down to under 50 degrees, I think it is. And this particular mixer I think goes to 45 degrees. I've got the same one attached to the hot taps, same model rather. So in here you've got hot water coming from the boiler, or it will be coming down here, and then it can mix with cold water which comes from the return line from the underfloor heating. So this is the return bit here, and it can take it from that, and then the leftover water, if you like, goes down the return line and then down there. That's going to have a T piece in it, and then this bit here is going off to the solar panels. But for the time being I'm going to put a lever valve on that, so I'll be able to isolate the solar panels with a lever valve here at the end of this pipe, and that way I can drain down the solar panels if I need to without having to drain the whole system. We're very slowly filling up the heating system again from that tank there. Due to a bit of a cock up with the plumbing, I neglected to put a feed on the little expansion tank on the heating system, so I'm having to fill it through this hose pipe. Goes through that window up to there. Fire's been lit for a while then. It's still not that warm, I'm still wearing my coat and the hat. But the circuit here is properly hot now. So it's the next morning. the range is stone cold. So you can see there the temperature in the tank is just over 60 degrees. What I'm going to do then is try using the new system to pull this water down here, which will hopefully be warmed by that water that's in the hot tank, and get some warmth into the floor. Pump on then. You can see already then there's a huge leap. So what I'm interested in trying to do here is to give the floor a kickstart in the morning, as it were. So as soon as I start working on solar hot water, we get covered in snow. Brilliant. As you can see, there's a tiny bit of snow left, but nearly all of it's gone now. Before I mount them onto the wall, I'm going to do something I've been meaning to do for a very long time, and that's jet wash all this flaky paint off and repaint the wall. It might seem like a daft time of year to be painting, and yeah, it is really, but this is a south-facing wall, so as long as I paint it on a day when it's sunny like this, there'll be plenty of warmth in there to make the paint go off. I think I'll jet wash the panels as well once I've done the wall. They are filthy. It was barn paint that I painted that with. That's what it's sold as, barn paint. It's acrylic paint. And on the sides it's actually held quite well. But on that south-facing section of the barn, yeah, it's just all cracked and fallen off, as you can see. So hopefully the bitumen will do a better job. This is the side of the workshop, and this is what I'm going for on the barn, this sort of thing. So when I got these panels, these shed panels that I used to make the workshop up, they had this strange red paint on all over it, which was flaking just like that paint on the barn. So I jet washed it all off, and this is 2 coats of bitumen over that, and it sort of toned the red down really quite nicely. So it has a sort of a tint rather than an offensive in your face red like this shirt probably appears to be on camera. So yeah, hopefully it'll be something like that. So this is what bitumen goes like in the sunlight. It goes a very matte black. Right, finally finished painting the walls then. They will matte down. It's very shiny black at the moment, but they will go matte quite quickly and look pretty good, I think. Okay, so now that's done, we can get the panels on and yeah, take it from there. Right, having jet washed these, there's still plenty of filth apparent, which is on the inside of the glass. So I need to take the glass out and clean it, but it also tells me that the sealing must have failed for that filth we've got in there in the first place. Now this panel here, this glass panel, I know for definite, because I broke one, that this is just normal household glass. And I'm slightly dubious about putting this on the side of the barn. It's going to be a tad vulnerable. Now what I considered was covering it in a protective film like you get for patio doors. That's supposed to stop it breaking. It's the idea, this is how laminated glass works. Proper laminated glass has a glass, plastic film and then glass, so it's a sandwich, like on your windscreen. So you can buy a film to put over it, but it turns out that's really expensive. The other option I'm thinking is, what I might do is get this glass out of the aluminium frame, put a sheet of acrylic, like Perspex stuff, and then put the glass in. And then that would add a bit more insulation to it. It wouldn't cut down on the light transmission too much, but it would make it a lot safer. I think for now I'm just going to clean it, install it all, because this experiment might not even work. So before I get carried away, I think it's probably wise to just actually fit it. Yeah, I can always take this off again. If I don't glue it on, I can take this off and mess about with it later. So, as I expected, not a lot to it really. The bulk of this here is insulation. I suspect it's probably fiberglass or rock wool insulation like you'd have in a loft. This seems to be a sheet of copper, and then it's got some copper pipe running through it. That's all there is to it really. Yeah. There we go. It's not quite like I thought. It's not rock wool or fiberglass, which is good. It's like Celotex. So it's that solid type of insulation. One of the panels had a whole length of this sort of aluminium angle, which I chopped up into 8 pieces just to make some simple brackets. So we've got a hole there for a bolt to go through, an 8mm bolt to go through into the actual panel, and I made a whole bunch of holes here on this bit to give me loads of screw points to put in there into the wall. One of the nice things about the barn is it's because it's wooden walls and a steel roof, it's actually quite easy to attach things to. So this is the bit of plumbing that I did before. This then has to meet up with the bottom of the solar collectors outside. Now I could just run the pipe along there and step over it every time I want to get out the door, but tempting as it is, I think I'll have a go doing it a little bit better. Ow. Here's my pipe bender then. It's yeah, it's not great. But it does go up to, it will bend 28mm pipe. I actually found this, or I found bits of it, and I had to make the rest. Yeah, it kind of works. That's that should be the first bit. Yeah, so we're coming from the wall, round the wall, down under the step. Yes, that actually worked. Crikey. So while I'm at it with plumbing in the solar hot water system, and while I'm doing some plumbing, I thought I might as well sort out the range So you might remember from a previous video that the flue came out the back and went up there and then out through this hole here. And that was a big mistake. The idea of it was to give more heat out into the room by having some flue inside, but it turned out that that actually just ruined the draw of the fire, and it didn't work as well. And it tended to leave soot on the inside here, and it was all just around about there. So that's frustrated me for quite a while now. So all winter I've been looking forward to this moment of rerouting it. So instead of going through that hole there, and instead of coming out the back of the burner down here, it's going to come out the side, which I think you can just about see, and I'm going to go out through that hole there, which was actually the original hole when I first test fitted this thing donkeys years ago. Now it's almost dark. I just had the idea I can go and get my laser level. It's a really puny laser level, but it'll work in this twilight, and then I can judge where to put the next bracket for the rest of the flue pipe. There we go. You should be able to see there a chalk line, and that's as a result of all that messing about with the laser level. Just a case of tweaking it now, putting on the locking bands and tightening up the bracket, and we'll be there. I can tell already it's working loads better. So always previously, if I had this door open, here, the smoke wouldn't move properly. But look, the drawer is so good now, even with this open, all the flames are going in the right direction. Crikey. And if I close that, it's never done that before. Brilliant. So that's a big leap forward, I suppose. Looks utterly unremarkable on film, I guarantee it, but yeah, I'm very happy with that. Nearly there with the pipe work then. This tape is where the pipe's going to come down from there. There's a bit of copper pipe sticking through from the sleeping loft. And I'm going to run this plastic pipe from there down to here. And here it goes from 22mm, so reducing T down to 15 on each side, going in this panel, and then I'll go over to this panel. Meanwhile down here we've got another reducing T, so that goes into the pipe that sits on the floor inside the kitchen. 15mm there, 15mm there. I've got to find an offcut to bridge this gap. And then here I've put in an equal T and a little drain cock, because this is going to be the lowest point of the system, so that when I need to drain it down I'll use that. Right, the system's been filled up. So it looks like in the time between pressure testing the solar panels and actually installing them, at least one of them has got a massive leak. Well, that's boring. That's that for now then. I'm going to have to take that one off and have a look at it, see if it's either repairable, or I'll take some parts from one of the other two that are left over and fix it, install it and try again. You join me in the workshop for the autopsy of the dead panel. Now I've dismantled it even more, you can see just how simple, you can see again just how simple these things are. Let's flip this over. See, it's nothing more than a sheet of copper with one continuous loop of pipe soldered onto it. Now I tested these panels, I pressure tested them, and that's why I was quite irritated when this one was leaking. But then when I considered when I pressure tested them, I still can't quite remember, but it was at least 6, maybe 7, maybe more years ago. Obviously since then, I suspect what's happened is I've stored this the wrong way up and some water has collected in the bottom here and subsequently frozen and popped out the side. So it didn't take much inspection to see where the problem lay. So that's frost damage. That's yeah, just popped its way out. So I'm going to have a quick go at fixing it, I think. The trouble with trying to solder up that hole is 1, it's quite a big hole, 2, I'm not really good at soldering, and 3, this pipe is all soldered onto this panel which will just start to lift off as soon as I apply any heat. So yeah, I'm not that hopeful it's going to be a good repair or even possible, but I'll have a go. Well, if nothing else, that's probably the first time you've seen someone try and do soldering with a oxypropane torch. Frankly, I'm amazed. That's now under pressure and there's no trace of any leak. Oh. Put it back together. Thank you. Can't really do much now until the sun comes out. I will point out I haven't put any antifreeze in the system yet. I will do that once I'm confident it all works and yeah, it's not going to leak and it's all going to stay like that. I will dollop some in. The other thing I'm going to do once this is up and running is insulate the pipes as they go up into the sleeping loft. I shall put pipe insulation over them all the way through to the heat exchanger and the hot tank. Just one further thing I should mention is that this is a vented system. It's not sealed and it's vented to the atmosphere, so like the rest of the hot water system, the radiators and the underfloor heating and the range and the whole thing is all connected. It's all fed from an expansion tank up in the loft space, and at the very highest point of the system is a vent pipe, and were the worst to happen, if these panels did manage to produce some boiling water or steam, it does have somewhere to vent. So I have thought through the implications of it overheating, and there is somewhere for it to vent off in that situation. I've also got the isolators, so I can isolate these panels off and drain them down. If I was going away, for instance, just to be on the safe side, I guess I'd probably do that. Yeah, shut them off, drain them down at the front, collect in a bucket because it's going to have antifreeze in it. Then those panels are just panels, there's no water in them to overheat at that point. Right, it's been about 4 days since I installed these and I've still no idea if they work because, well, let me show you the sky. See, I hope the camera can do justice to the sheer level of gloom that we have just weighing upon us here. The one consolation is that I planted a few hundred hedging plants about a week and a half, 2 weeks ago, and with all this rain at least they've really been soaked in, so that is one consolation. That's the best possible start for those plants. Other than that, man, it's just utterly uninspiring this weather. The solar electric panels on the roof there are making less than 100 watts between both arrays. Well, that's less than a tenth of what it would do in direct sunlight, so that gives you an idea of how just murky it is. So what I'm going to do then is split this video. This will be a part 1 and I'll do a part 2 where I'll do a follow-up and see if it works, and if it works well, and problems I encounter and things like that. So as soon as the sun comes out I'll film a follow-up. What I'm trying to achieve, what my best case scenario is with this thermosiphon system. So bear in mind it's got no pump for this. I'm relying purely on gravity and the differing densities of hot water versus cold water to move this around the system. That's the idea. And that works with my radiators in there, so I'm hoping it'll work with this. I've designed it with the same thing in mind. What I'm hoping to do then is to make a system, and I'm not saying it's superior to what you'd normally have with solar hot water, is obviously a pump, and you'd have a controller, and the controller would switch on the pump when it's needed, when there's enough heat in the system there to put it into the hot water tank, and so on and so forth. What I'm hoping to do is something that self-regulates, like the radiator system in there. So when I've got my radiators on and I've got the range going, that system can't overheat, because the more heat I get in the range, the faster the heat will circulate through the radiators, and the radiators can give out more heat than the range can produce. So the whole system's safe and it's self-regulating in a sense. I'm hoping the best case scenario is that this will achieve the same thing, so that heat from these panels will go into the hot water tank, and when the hot water tank is hot, the excess heat will go round the radiator system. So even if I'm not here and this is on, it will still sort itself out safely. That's again, that's the idea, and this is the experiment to see if that works. When I am here, I would then have the choice of taking the heat from these panels and pumping it into the floor by switching on the pump that I do have, which runs the underfloor heating, and that will interrupt that circuit that goes from here up to the hot water tank. It'll interrupt it and pump it into the floor. So again, that's an experiment, and what I'm trying to do with that is to see if I can get the floor heated during the day so that it gives out heat in the evening. So on spring and autumn days where it's nice and sunny but cold at night, it'll take care of that, and it should mean that I'll have to use the fires less, which will be a good thing. So those are the aims. Here's the experiment, and stay tuned for the results. See you in part 2. Cheers.